Okay, welcome back to day 2 of the Alum Crystal Lab, where we're trying to see how certain types of matter called crystalline solids will arrange themselves into regular repeating patterns when they form. The instructions will be posted, of course, over here on the display board, so if you forget something, just check it out there. Okay, the step 1 says make a new solution of alum just like we did yesterday. So we're going to use today 11 grams of water instead of, 11 grams of alum instead of the 8 grams we used yesterday. So let's balance the balance by putting both riders at 0 and patiently waiting to see if the balance balances. It looks pretty darn good. Put the weigh boat on. Remember, it weighs around 2.2, 2.3. Let's see what it is. And it looks like today the weigh boat's weighing in at 2.3 grams. Now I need 11 grams of alum, so I take 11 plus 2.3, and that would be 13.3. So I set this to 10, and I set that to 3.3. So that would be 13.3. So when we put 11 grams in here, the weight of the 11 grams plus the 2.3 grams there will give us the 13.3, and we'll know we have the right amount of alum. So we'll go ahead and put the alum in there, and when the balance balances, we know we've got our 11 grams that we're looking for. Okay, so you know the deal. You get too much, you got to take it out. You don't have enough, you put it in. And ladies and gentlemen, there we have a balanced balance. So we are good to go now with 11 grams of alum. Okay, next thing we need to do is to measure out 50 milliliters of water this time. So please remember the steps with that. You will take and put the water in the cup. You never put the graduated cylinder directly under the faucet. Put water in the cup. We then look at our graduated cylinder, see where we need to go. Pour it into the bottom of the meniscus. Is right at the 50 line, which it is, and there we go. Then, as you recall, we will put the water in the flask, and then we will put our alum in the flask. And then we'll heat her up, and we'll check it out. Okay, so we've heated up our solution, wearing our safety goggles, of course. And now the instructions say to let it cool for about 10 minutes. So let me show you what happens if you don't let it cool. If you pour it in right away into the plastic cup, what happens is that the cup, being made out of plastic, deforms, melts, has all kinds of issues, and spills the solution all over the table, creating a huge mess of hot, ucky stuff. So please, unless you want to ruin your experiment by ruining the cup, wait the 10 minutes to let it cool. You can either talk with your lab partners, or you can just sit down and relax a little bit there. There might be some other things we'll ask you to do. So that's pretty critical. So, at any rate, well, I guess we have to make another solution now.